13, 14, 15, we're solving compound linear inequalities. It says that if there's no solution, enter the empty set for the no solution symbol. And so what we're going to do here is we have to solve each of these. Keeping in mind, if it's an and, I should be between two numbers. If it's an or, I should be going in the two opposite directions. And that's why we have no solution sometimes, because it doesn't fit the meaning of and or. So I want to start out by just solving each of these separately. 4x plus 3 is greater than 19. I'm going to minus my 3, so 4x is greater than 16. Divide by 4, so x is greater than 4. Here, 3x minus 1 is greater than or equal to negative 10. I'm going to add my 1. 3x is greater than or equal to negative 9. I'm going to divide by 3. X is greater than or equal to negative 3. So in this case, I want to figure out on my number line, I am greater than the 4. Wherever 4 is, I'm going this way. And I'm greater than or equal to negative 3. Filled in dot, I'm still going this way. When I am doing an and, I want those values that are in both sets of my answer. So I want the section that's overlapping each other. So on my answer, I am just doing this section that's greater than or 4 because those numbers are included in both of my sets. So I would say 4 to infinity, not including the 4, so I'm going to have a parenthesis, and I can't include infinity, so I'll have a parenthesis on that end also. So my solution in interval notation is that I'm going from 4 to infinity. So number 14, if I'm going to solve that one, I have 2w plus 2 is greater than or equal to 14. I would minus my 2. 2w is greater than or equal to 12 and divide by 2. w is greater than or equal to 6. On my other one, 3w minus 2 is less than or equal to, whoops, I'm trying to add my 2 already, 7. I'm going to add my 2. 3w is less than or equal to 9. Divide by 3. w is less than or equal to 3. So this one's an or. Means it can be in either set. So I am greater than or equal to 6. I'm going this way. I'm less than or equal to 3. I'm going this way. Both of them have the filled in dots because they both have the or equal to. So I want to write that I'm in this set or this set. Anything that got shaded in either section is part of my answer since it's an or. So this section is going from negative infinity to 3. And this section is going from 6 to positive infinity. Brackets on the 3 and the 6 because they did have the filled in dots. So number 15, if I'm going to solve that, I have negative 3v is less than 6. I'm going to divide by my negative 3, which means I need to flip my inequality, and v is greater than negative 2. Then we have 2v minus 1 is less than or equal to 7, so we're going to add our 1. 2v is less than or equal to 8. Divide by 2, so v is less than or equal to 4. This one has or in between it again. So on our number line, we have negative 2 with an open circle going this way. We have 4 with a filled in dot going this way. Now this was an or, and so anything that got shaded on your number line is part of your answer. If it was an and, you just do this section in the middle. But if it's an or, anything that's shaded is part of your answer. Well, I'm shading here, but I still keep going because I'm shading down there. So my answer on this one is that I shaded all the numbers from negative infinity to positive infinity is either a value that's greater than negative 2 or a value that's less than or equal to 4. So every number would fit into that list. And so my answer would look like that.